Hey everybody, welcome to another IAEI News Live. My name is Thomas Dimitrovich, and today's discussion is on 100% rated solutions. We're going to dig into some of the details, help you understand what a 100% rated overcurrent protected device is. And it all starts now. All right, welcome. Welcome to another IAEI News Live, everybody. And can't wait for the discussion today because we're talking 100% rated overcurrent devices. And I know there's a lot of confusion around that. For a while, I was confused as well. So information was shared with me many years ago on this topic. And I'm going to share some of what I know with you and point you in the right direction with regard to understanding how to navigate the National Electrical Code. How to we'll walk through and try to understand why overcurrent devices are rated the way they are. But before we go there, I do want to remind you that we have IAEI section meetings coming up. And I'll show you how to navigate to find the information so that you know what is happening, when, and where, and how to get to the registrations. So this is what you do. You go to IAEI. Oh, you gotta type on the right keyboard. Go to IAEI.org. That's your first step. And you'll find out that the IAEI International Office is closed for Labor Day. The IAEI's analysis of code changes is out. Get yours ordered. And also, just another piece of information, NFPA Link now has the 2023 code book online. So if you have purchased NFPA Link, then you have access to the 2023 code online. And if you haven't purchased NFPA Link, you got to get over there to NFPA's website, get yourself a membership to NFPA Link, and start reading the code book. It's great to see some of the changes, and you'll love every minute of it. And especially if you're going to go to some of these IAEI meetings, you could load NFPA Link onto your iPad, onto your phone, and download that information so that you're ready with you could even download the previous editions of the code. So whatever code edition that you are on, go out to NFPA's website. Get engaged with NFPA Link. I tell you, I'm a believer in it now. I've been using it heavily recently, and I'm loving it, every minute of it. All right, so let's talk IAEI first. Education. If you go to education and just hover your mouse over it, and you come down to section meetings, you can also go and find local events in your city. But go to the section meetings. That's what I want to talk about right now. September 11th through the 15th is the Southwestern and Northwestern section meeting. Those are a combined meeting. So if you open in a new tab, if you click on that link, you'll come to the Northwestern section meeting website. You can see who are the board of directors, and who's the education chair, Chris Jensen, membership chair, Jeff Fitzloff. And if you become a member and you are in the Southwestern or Northwest, these individuals will love you because you're a new family member. So you're going to want to get out there and take a look at what the section meeting, and then also join the IAEI. You'll become a member of whichever section that you are engaged with, and there's a lot of opportunities for you in education and networking. Don't underestimate the power of building friendships in the electrical industry. So there is you can be an exhibitor. You can download information and a registration form. You can reserve online. You can have an attendee. The hotel do your hotel reservations. let's take a look at the attendee registration. Don't wait, register now. I love it. These guys are good. Click here for ads, printable registration form, companion programs. I wonder what they're doing for the companion. Let's take a look at the companion program. So on Monday, they're going to winery luncheon. They're going to have a Mary Hill winery luncheon. That's pretty cool. Longhorn barbecue. They got some free time. Tuesday, they're going to have a walking tour, riverfront. Then we have the IAEI banquet. Then they have Scrubbies demonstration in the hospitality room. That's kind of cool. They have a welcoming reception. So some cool things for the companions, the companion program. Let's take a look what they have on this. So there's the program agenda. So you can see what's going on. Let's take a closer look. Like that. All right. Monday. So they have a reception in the evening. In the Monday, so the first at each of the section meetings, they'll kick off with a business meeting. Usually, they'll have words from our El Presidente, our CEO, Rudy Garza. IAEI International CEO will speak. NFPA will speak. ICC will speak. Steve Jones of SEAC will speak. Mike Stone from NEMA. What else? Section business. They'll go through the bylaws, all that jazz. Emergency, legally required and optional standby is Education Module 1. They'll have a keynote speaker, optional standby systems, circuit integrity systems, UL 1724, UL 2196. Emergency and legally required standby systems, Article 700 and 701. Then they have the Longhorn barbecue. Gotta love it. Code breakfast the next day. I love, here's the thing. I love the code breakfast. Each of the section meeting does something a little different. Each section meeting. The Southwestern, the Northwestern, the Western section. The Western section, we've got Borgie Knoll, and he does a code breakfast. The Eastern section, really great morning sessions. I tell you what, those sessions, I learn a lot. 2023 significant changes, Don Iverson. You've got a networking lunch. Education Module 3 is alternative energy. You got photovoltaics with Pete Jackson, the man, the legend. He's awesome. Pete is a great guy to learn something from. Energy storage systems from Doug Smith. Installation of awards, all that good stuff. And then Wednesday, they've got electrical fundamentals, terminations and conductor sizing, grounding and bonding, electric vehicle power transfer systems, NEC 625, fire pumps, 695 from the Chuck Mello. And then Thursday, you've got healthcare facilities, you've got motor fuel dispensing facilities, and then cannabis facilities. All right, so that's the South and Northwestern section meetings. That is on the September 11th through 15th. Western section, gotta love the Western section. Gotta be there. I'm gonna be there. We have our registration. We have the meeting. Code panel questions. Let's take a look at those. It's actually opening up a document in the background. So, link to registration page. Let's take a look at that. Purchase ads. You can contribute code question Q&A. General registration. There's a registration form. And these things are downloading in the background. I'm not sure why. But anyway, you can go out to the registration page. We have a Mr. Larry Ayer, who's the Core Link Committee Chair, is going to kick us off. We're going to go into NEC 2023 code changes. We're going to have code Q&A. We have a keynote presentation on Wednesday, I believe, with the Jimmy Rogers, who's chair of Code Making Panel 4, and he's going to be talking about alternative energy solutions. So you have code Q&A, and the Q&As are really good. You have Charlie Trout Code Breakfast on Wednesday morning. So there's a lot of great stuff going on the Western section. We have a whole lineup. We're going to go through each of the code making panels and understand the big changes in regard to the National Electrical Code, the 2023 edition of the NEC. Eastern section, that's September 30th through October 2nd. So the Western section is in Sioux Falls, South Dakota. The Eastern section is in Lancaster, Pennsylvania. Take a look at what they've got. Click here to register, make a hotel reservations. Let's take a look at registering. Oh, download the meeting agenda. Go back to download the meeting agenda. There we go. See, that one downloaded. The other ones, I don't know what was going on in the background. So here's the meeting agenda. I'm telling you, their code breakfasts are absolutely awesome. Not from from the food perspective too, but from the sharing of information, the debating, the arguing, the back and forth. It's just phenomenal. They have and then looks like they just have training, breakout sessions. So I believe they're doing a lot of 2023 code changes. They don't have the details on there. Canadian section, that's September 23rd through the 25th. So for all of our Canadians out there, looks like Thursday the 22nd, they have 2021 CE code and beyond. 22nd, Thursday the 22nd, they've got remote field evaluations. That's an upcoming thing. Correlation between the CE code and National Building Code of Canada. Artisares. And closing remarks. Friday, closed meeting for board members. So this whole remote field evaluation, that's a, if you think, here's my thoughts. COVID has caused our industry to take another look at alternative solutions. It's not just our industry, many industries. The remote capabilities are being explored, and I think the whole work at home, keep yourself out of harm's way from a germs and virus perspective, forced us to take a look at these other solutions, and remote field evaluations or remote inspections are some things that I think are attractive. Just from a safety perspective, from a ability to see things and document the installation process. Absolutely phenomenal. And then you have the southern section, October 9th through the 12th. October 9th through the 12th. All right, bylaws, operating rules, download registration form. Let's take a look at let's take a look at the registration form. I know they're doing a lot of 2023 code changes, and I know they're doing continuing education. I don't see the agenda. I know they're doing code changes and code questions. So I don't see their, I'm going to just take a look at their registration online. They're using Eventbrite as well. All right, well, okay, I don't see their complete agenda. But that's the, those are the section meetings. So explore out there. It's great to get back in person again and meet and talk to people, because I think that we need to do more of that. In my opinion, we need to get ourselves more engaged with each other moving forward. Leverage that online experience where possible, but get engaged with the section meetings. All right, so now let's talk 100% rated. Here's the thing with 100% rated overcurrent protective devices. I'm going to call up NFPA link. And what I do is I go to nfpa.org/70, and then where I have a subscription to NFPA link, it says subscribe. I do a sign in, put my user ID and password in, and there it is. And the 2023 code is right there. I'll show you what it looks like. There it is. And there is the 2023 code right there. There's my 2020 code. There's my 2017 code. I've got 70B up, 70E, 101, 110, and 111. Gotta love it. Gotta love it. All right, so I got the book up. Let's talk about 100% rated breakers. So when we think about overcurrent protective devices and the whole concept of 80% versus 100%, think about the heat that is generated inside of the enclosure. And at certain places inside of that enclosure, we will measure temperature. And when we say temperature, what we look for is a temperature rise within those terminations, within whatever it is I'm monitoring inside of that enclosure. And what we're going to talk about is in regard to the overcurrent protective device. But this whole concept of 100% versus 80%, the 101.25, all that is a general, it's a heat rise concern, not just for overcurrent protected devices. For transformer, if you look at some of your transformers, they'll have a temperature rise. They'll tell you to use 1.25 in some cases. Just a simple enclosure with terminal blocks. It doesn't have to be an overcurrent protective device for you to have a temperature rise concern, because it impacts all of these different components inside of the enclosure. So just keep that in mind, that when we say 80% and 100%, we're not necessarily just speaking about breakers, but this discussion will be, but just think about it from a heat perspective in an enclosure. So how do I generate heat? I generate heat with resistance and current, I squared R. Right? So when I put current through a conductor, I put current through a termination, I will generate heat. And I can't have a heat rise in that enclosure greater than whatever the standards tell me based upon all of my different measuring points. And so I'm worried about heat. And we do various things to get the heat out. We could increase the conductor size a little bit larger than what we need, maybe 125%, right? I could increase the enclosure size. I could increase the bus bar size. I could change the materials I make the bus bar out of that the overcurrent device terminates on. We'll do different things to address heat inside of the enclosure. And unfortunately, a lot of people will think that all I need to do is buy a 100% rated circuit breaker, but I hope you understand why that's not 100% accurate. 100% rated breaker might not be 100% accurate. That's kind of cool. Anyway, whoops, wrong button. All right, so in reality, and this is my opinion only, believe half of what you hear and less of what you see. That's what I always say. Question, question, question. Do your homework. Don't do for the student what the student can do for themselves. But the way I look at it, my load calculation is where I'm beginning in my journey and decision around 100% rated versus 80% rated. So what do? We calculate a load currents on conductors, right? And we have to make a decision. What is a continuous load versus a non-continuous load? We have to identify those. So what is a continuous load? Let's go to the definition. I know what it is, but I'm not going to just say it because I want to be as accurate as I can and make sure I have the right. If you look in the definition, it is continuous load, not continuous amps, not continuous, it's continuous load. And it just tells you it's the maximum current expected to continue for 3 hours or more. So when you think about loads, lighting, you think your lights are going to be on 3 hours or more. When you think about hot water tank, will it be on for 3 hours or more? Dishwashers, dryers, what other loads? Pumps, your Marshall half stack. When you play, do you play guitar 3 hours or more? Just kidding. I'm just trying to think of various loads. Just you can think about the loads in your facility. HVAC equipment, 3 hours or more. All these different types of loads you will have to consider. Are they continuous or not? Then you make a decision based on that, right? And when do you make that decision is when you are calculating, keep putting the wrong number, the ampacity of things like conductors or busway, right? So let's go take a look from an ampacity perspective. So we know a continuous load is the maximum current that's basically going to continue for more than 3 hours, 3 hours or more. Because that's the other key thing is, do you say more than 3 hours or 3 hours or more? And that was the reason why I went to the definition to make sure I was going to use the right word there. So ampacity is a maximum current in amps and ampacity relates to conductors, and it's the maximum current that a conductor can carry continuously under the conditions of use and without exceeding its temperature rating. So ampacity is based upon conditions of use. It's not a rating. We already went through that last code cycle. We got rid of all of the rated ampacity references. We also got rid of the allowable ampacity terminology. It's just ampacity based on conditions of use. And it's the maximum current that you can run continuously on that conductor, continuously, without exceeding the temperature rating of its insulation. So then now that you know what continuous loads, and if you know what a continuous load is, then you know what a non-continuous load is. And you know what ampacity is. Now you get into Article 210 for branch circuits, 215 for feeders, 230.42, not 23042, 230.42 for minimum size and ampacity. Now, remember, this is when you're going to size the conductor, right? So this is an important part of the decision tree. So we're in 210. We'll go to 210.19 real quick. All right, so branch circuit conductors, this is your minimum ampacity size. Ampacity and size. So it says, and this is not exceeding 1,000 volts, because remember, we moved all of the medium voltage stuff out of 210. We put that over to 235. So 210 is just, you're not over 1,000 volts AC or 1,500 volt DC. So 210.19. A is your general requirements. What A is going to give you are two, it's going to tell you, look, you're going to do two calculations. Whichever one results in the larger conductor is the ampacity that you need for that conductor. That's the conductor size you're going to use. So in the first calculation, you take when you have continuous loads, you have to take the 125% of the continuous load and add that to the non-continuous load. So whenever we think of 125%, it's only in relation to continuous loads. That's when I'll do my calculation. So I do that calculation. I come up with an amp value. And then I do a 310, I go to 310.14 to pick my conductor. And then the second calculation I go to the minimum branch circuit conductor size, which will have an ampacity not less than the maximum load to be served after the application of adjustment and correction factors. So the first one, I don't do adjustment and correction factors. all I do is 1.25 times the continuous plus the non-continuous. In the second calculation, I don't worry about the 1.25. I just do the adjustment factors or correction factors. So I'm looking at how many conductors are in a raceway. I'm looking at the temperature. Those are the two that I'm going to apply. I don't do that in the first one, but I do it in the second one. Now, there is an exception. There's one exception to 1 and 2. If the branch circuit is connected, both its supply and load ends separately installed, pressure connections, allowable ampacity in accordance with 310.15, not less than the sum of the continuous. No portion of the branch circuit installed under this exception shall extend into an enclosure. So what this is giving you the ability to do is, if you are not landing in an enclosure with the overcurrent protected devices, if you are at both ends, the supply and the load side, you have separately installed pressure connections as covered in 110.14C2. 110.14 is your terminations. The allowable ampacity is not less than the sum of the continuous load plus the non-continuous load. You don't have the 1.25s. So you're just looking at, remember, a conductor has both two ends, right? So, and you can't forget about 110.14. Don't forget about that one. So you have a conductor. You're going to do these two calculations. You're trying to pick and select your conductor size. You're either going to use the 1.25 or you're not going to use the 1.25. Now, after you're done with this, then you're going to go to 210.20, and what 210.20 tells you, that's the very next section in 210, where a branch circuit supplies continuous loads or any combination of continuous and non-continuous, the rating of the overcurrent device shall not be less than the non-continuous load plus 125% of the continuous load. So you pick your conductor based upon that previous calculation, where you're doing the continuous on the 1.25 and not considering the adjustment factors, and then you're doing your adjustment factors not considering the 1.25. Whichever one is the greater, that's the one you're going to use. But then what you do is you pick your overcurrent protective device to protect the conductor. And then you have to follow 210.20 that says your overcurrent protective device has to be greater than 1.25 times the continuous plus the non-continuous. So even though 210.19 doesn't have you do that, you're going to have to do it here. And quite frankly, if your number was smaller, that's probably going to be your larger of the two. Doing the correction, I mean, it has to be a really bad location to make the adjustment factors and the correction factors be more than a 1.25, in my opinion. You might think that's 100% wrong. That's okay. Put it down in the comments. Remember, your feedback, your dialogue is just as important as mine. So please comment on these videos. So you have those two things to think about. The 1.25 times the continuous, not the non-continuous. And if you don't have continuous loads, then you're not at the 1.25, right? If you're all non-continuous loads, then you don't have to worry about the 1.25. 1.25, that 80% is only for the continuous loads. Now, okay, so you got those two calculations going on. Now, 210.20 says, where the assembly, including the overcurrent device protecting the branch circuits, is listed for operation at 100% of its rating, the ampere rating of the overcurrent device shall be permitted to be not less than the sum of the continuous load plus the non-continuous. This is where we introduce the concept of 100% rated. But read that exception closely. Where the assembly, including the overcurrent protective devices, where the assembly and the overcurrent protective devices Can't miss that. So you have the similar language in 215. You've got 210 and 210.20, 210.19 and 20. You have 215.2, minimum rating and size, 215.3, overcurrent protection. And you've got minimum size and ampacity, 230.42. That's for services. Services are a little different. So there's a little bit of a difference there. Let's focus on the 210 and the 215 because I want to help you understand 100% rated. Those are the two easy ones to comprehend in the time we have. Now, let's go to the overcurrent protective device and understand what the UL standard, which is UL 49 for the molded case circuit breaker. What does UL 49 say about 100% rated? In section 7.1.4.3, they tell you that you have to put the breaker, when you're going to test a breaker and mark it, mark, not mark it like sell, but mark it as 100% rated, you want to put it in its smallest enclosure it is intended to be used. Or if you do it in open air, they have you do a sequence. Now, temperature rises where the connections are made. And I remember I mentioned this earlier. Where the connections are made to external bus bars, when bus bars are used, or on a wiring terminal at a point in which the insulation of a wire is brought up as in actual service, when tested with the insulation wire, shall not exceed 108 degrees Fahrenheit, 60 degrees C. The marking is permitted to indicate only specific current ratings if a rating less than the frame rating does not exceed 90 degrees Fahrenheit, 50 degrees C, temperature rise. Now, the key things here, I'm measuring temperature at certain locations on this overcurrent device. And I have the smallest box size. Now look at this next one. Circuit breakers have to be connected with copper bus bars if the circuit breaker is intended for use with both bus bars and wiring terminals. So what does that tell you? You have a panel board and it's got aluminum bus, and you have a breaker and you want 100% rate, and you go, oh, I got to go buy a new breaker. Your panel board construction makes a difference. You just don't take a 100% rated breaker and stick it into an enclosure and say, I'm 100% rated. It's more than just the overcurrent protective device. You've got to think about the enclosure, the assembly. So unless the breaker is marked to indicate otherwise, the bus bars have to have a cross section of 1.55 amps per millimeter squared, amps per inch squared, 1,000. For ratings less than 1,600 amps. For ratings 1,600 amps and higher, the bus bars shall be in accordance with, there's a specific table in there. So the dimensions, the material of the bus bar makes a difference. The size of the enclosure makes a difference. The construction of the bus that you're going to be terminating that breaker onto makes a difference. I think it's safe to say it's not just about changing out a circuit breaker. You need to look at the assembly, and that's why in 210.20 it says, where the assembly, including the overcurrent devices. Now, what you'll see, circuit breakers frame size of 250 amps or greater, if it's a multi-pole type or any ampere rating over 250 volts, shall be marked suitable for continuous operation at 100% of rating only if used in a circuit breaker enclosure. So they're telling you exactly which enclosure, or in a cubical space so many inches by so many inches by so many inches. Equivalent wording shall be permitted. So here's the thing. The size of the enclosure, the material, that the bus is made out of, that you're going to be mounting that overcurrent device onto. The construction of that bus, whether it be the material that it's used or even the thickness that it's used, all make a difference. So then we look at the panel board. Panel board maximum continuous current that can be supplied through the main terminals is the current rating of a panel board. And then it says, unless the assembly, including the overcurrent devices, remember what we just said, are marked for use at 100% of their current rating, overcurrent protection devices shall not be loaded continuously to more than 80% of their rating if nuisance opening of the device is to be avoided. Now, what does that 125% do? When you start with the current, remember, we're starting with current of the load, continuous current. Let's say it's 100% continuous current, and it's 100 amps of continuous current. 1.25 times 100 is 125 amps of continuous current. Then you pick your conductor. So you have 100 amps, and you can use 100 amps worth of conductor. But you don't buy 100 amps worth of conductor. You go to 125 amps of conductor. Remember, the ampacity of the conductor has to handle the amps. You can't say, I'm going to go to the next size conductor up. You pick the conductor for the amps. Then you pick the overcurrent protective device. And the overcurrent protective device can be one step higher than the stand. If it's a 125 and you can't buy a 125 amp breaker, you can buy 150. You can put 150 on it because it's the next standard breaker. And so as long as you meet the other rules, right? But in any case, the conductor has to carry the current continuously. So your conductor, your 100 amps of load current, where you could have used 100 amps worth of conductor, now you're going to use 125 amps worth of conductor. So you're increasing the conductor size. And what do we do when we increase a conductor size? We're adding more material, more copper. What does that help us do? Take the heat out. It helps us take the heat out of the enclosure. Get wicket off wicket. Ooh, wicket off of the breaker. And if you're not going to have the conductor get the heat out, then you have to construct the panel differently, possibly the circuit breaker differently. That's why the bus might have to be a certain dimension. That's why the enclosure might have to be a certain size. But heat. So, if you go to a equipment manufacturer, look at this table. It says, circle 3, note 3, says 100% rated. And look, not all of those breakers are 100% rated. There's a CKD that's 100% rated and a CHKD. Those two specific circuit breakers are 100% rated, not the others. So not all circuit breakers are going to be 100% rated. Now, let's go to the panel board. The equipment to which the circuit breaker has to be installed also may have special requirements. And look at these. These are notes from a manufacturer selection of a panel board. Look what it says, note 5. 100% rated circuit breaker requires copper bus, and it's not available in a 12, 4, or 4X enclosure for that specific panel board. So if you had a situation where you needed 4X and you did your design way back in the load calculations and you did 100% of continuous, 100% of non-continuous, instead of doing the 1.25 times continuous, way back there, and you picked your conductors, which are going to be smaller than the 125%, and now you picked your circuit breaker and you go, oh boy, I need to make sure that's 100% rated. You have a 4X enclosure, you bought standard 80% rated breakers, you got an issue. You're going to have to change the panel board out in addition to the circuit breaker. It's not, remember, I'll follow that up at the end. I'll give you the key takeaways. So look at this. The equipment to which the circuit breaker will be selected. So this is showing you, if you look at note 7, it says 100% rated breaker requires copper bus. K and N frame breakers require density rated copper bus. So those two specific circuit breakers, if they're going to be placed in this catalog number of a manufacturer, though if you buy a K or an N frame from that manufacturer, you're going to need density rated copper bus. And, oh, by the way, it's not available in a type 12, 4, and 4X. It's not as simple as just replacing a circuit breaker. So, summary. 100% rated breakers aren't just about the breaker. You are making the decision back at the ampacity calculation when you select your conductor sizes. When you do your load calculation and you identify the continuous and non-continuous, if you did 100% of the continuous and you followed that through, you got to specify the right equipment. Because I'll tell you what, here's what happens. Somebody doesn't document what they did. A good inspector gets out there with their calculator, or maybe during plan review, hopefully in plan review. That's when you want it to be caught. And if you're in a jurisdiction where they do not do plan review, there are resources for you. Let me know you're interested in plan reviews. IAEI might be able to help you out in that review, in that regard. You're going to want to get your drawings reviewed. And then make sure that you catch all of these types of problems before you start buying product, and hopefully before you start installing product. Because once you have it installed and you decide that, oops, I made a mistake, then you are going to have a little bit more work to do in regard to making sure you meet the requirements for 80% rated breakers. If you bought 80% rated breakers instead of buying 100% rated breakers, then you're going to have to address the problem. And sometimes, more often than not, it's not a simple fix. So, what happens? So, why would we go down the road of 100% rated breakers? So why would we do this? Why would we do that? It permits me to use smaller conductors because we said earlier, I take my 100 amps or 1,000 amps, right? Instead of buying another conductor size up, I can buy a smaller conductor. And if I have a lot of feet of conductor, that can turn into a lot of money. So I will purchase a smaller conductor and save money. But whenever you make decisions like that, whenever you are doing series rated systems, remember we talked about series rated systems on this channel. I know we did. When you do a series rated system, a lot of people forget the fact. Let's talk about that. You go to, I believe it's in 240. I'm in my handy dandy. You have the marking requirements. So I'm in my NFPA link. It's kind of cool. If you don't have a copy of this, and use the right keyboard. 24086. If you got to get your copy because you could search it, you can bookmark it. I think you can even make notes. I don't know. Series ratings. So where a breaker is used to having an available fault current. So what is a series rated system? And the reason I'm going down this road while I'm talking about 100% rated, because I will series rate to save some money. I will do 100% rated to try to save some money. It may be that the 100% rated breaker and the equipment is less costly than the conductors. But what is really expensive and where it all goes out the door is when You bought the 80% because you didn't specify it correctly, and now you have to change it. Now all of that cost savings went out the door. So same thing on series ratings. In series ratings, remember, you can do a test. We have tested combinations, and when we do series ratings with tested combinations, we have an upstream device, we have a downstream device, and we pass current through both of them. Both devices see the same current. But when I have motor contribution that is, say, in a piano board, that where the fault current contributes in between the upstream and downstream device, I can't exceed 1% of the interrupting rating of the downstream device in my series rated pair with regard to the full load amps of that motor load. Why is that? Because the downstream device is going to see more current than the upstream device. And the circuit breaker or the circuit breaker infused combination has never been tested like that. So they limit the amount of difference in current that the downstream device can see as opposed to the upstream. Remember, the downstream device has the lower interrupting rating. The upstream device has the higher interrupting rating, and they're both going to operate and function together to clear the fault. So you do a series rated system, and you have motor contribution. You didn't consider 240.86c. That's your code reference. And now you have to fix the problem. It might not be that easy, and it's definitely not going to be inexpensive. You got to catch these things up front. Plan reviews are perfect for this type of activity. If you're not a code expert, if you're not the code guru, get your drawing together, get your specifications together. Call the IAEI. Tell them you want some help. And you might get some help. So, series rated systems. What are you doing? You're making some decisions to save some money. Cross your T's and dot your I's. 100% rated breakers. 100% rated solutions. Cross your T's and dot your I's. It's very important to get that done and do it correctly. Don't let your inspector find it in the field. Make sure that if you find a problem, you find it on the drawings first. You find it in your design first. Because once you have purchased product and installed product, it can be difficult. It can be expensive to remedy the situation. You definitely do not want to ignore it. Now, what I do want to do is talk about one last important topic before I let all of you go. I want to talk about your IAEI membership. If you go to your professional, you can have a professional membership. You can have a student membership. Look at this. If you are a student, it's complimentary. If you're a student, I would join. This would be a no-brainer for me. If I was a student of engineering, this is a no-brainer. Here's why. You get IAEI News, IAEI Magazine. IAEI Magazine. You have access. You get one of these, I believe it's quarterly, and there's a bonus edition, I think, if I'm not mistaken. I don't think it's monthly. It might be monthly. Oh, look at this. Electrical Fundamentals. Oh, wow, look at that. That's kind of cool. You have the magazine, you have the latest articles, you have magazine archives, you have authors list. If you want to write an article, submit an article. If you love to write and you like to educate and you like to teach, get an article put together. These are some of the hot topics in the magazine, and you get this magazine and all of its contents, not just what they elect to put on the web, as part of your membership. And if you're a student, you can learn a lot about the National Electrical Code. You can learn a lot about design, latest technologies. Look at some of the UL 2703 photovoltaic installations, and does UL certify Class 4 cable, special occupancy changes. The next edition of NEC, a transformational change in electrical safety. Significant changes to the 2023. Top changes from Codemaking Panel 7, Code Hunter, looking to the future, talking about photovoltaics, alternative energy storage systems, all that good stuff. What if GFCIs did not exist? ESFI, coordination studies between theory and practice. There's a lot of interesting, important materials that you may find of interest, and these are great technical documents. These are just a few. There are some columns, there's some sections, electrical fundamentals, inspections, industry standards, code adoption, magazine, author list, and you can take a look at a lot of the authors and terms and conditions, all that good stuff. So your membership, if you're in the electrical industry, this is, in my opinion, one of the most important memberships I think you can get. I didn't realize it till later in my career. I went through I graduated college with a electrical engineering degree focusing on power systems. So I graduated with a power systems engineering degree. I earned my EIT. I passed the EIT when I graduated. I studied for 5 years under professional engineers. And then I got my PE license. And throughout those first 5 years of my career, I did design. I worked at a nuclear power plant that was built in the 70s, and they gave me the 1970 whatever code book. And that's what we used because that's when the plant was built. I had to learn so much more material that I was never taught in school. But what I always say, for the engineers out there, it doesn't matter. School teaches you to learn a mass amount of information in a short period of time. It teaches you how to study. It trains your brain to be a sponge. Your learning will never stop. And what the IAEI has helped me with is build a network. I know a lot of individuals in the industry, and I learn from them. When I don't have the answer to a question, I might be calling Donnie Cook, Shelby County, Alabama. I might be calling David Williams out of Michigan. I might be calling Jimmy Rogers, Chair of Panel 4, Larry Ayre, Correlating Committee Chair, Mike Johnston, NECA, Jim Dollard, IBEW, Palmer Hickman, Electrical Training Alliance. I call people and I ask questions. And these people are all mentors to me and help me in my career, help me in my knowledge that helped my career. And that's all available to you. And it starts with getting engaged with organizations like IAEI. So my encouragement is get over to that website. Get over to the IAEI and go to IAEI.org. Go over to membership, and you'll see the different options. If you're a student, it's a no-brainer. Do it today. Get out there and do it. If you are a corporate member, you work for a company and you want to get a corporate membership, get over to corporate and senior memberships. Contact CMake, and when you click on this, you'll bring up your email. Professional, I have a professional membership. 1 year is $120. Best $120 you'll ever spend, in my opinion. You can click down here for all the different membership and values. The value that's provided. You get a discount on all the IAEI products. One-on-one technical advice. IAEI weekly industry digital newsletters. Monthly digital IAEI member newsletter. Member recognition, access to IAEI online communities. Professional development. Enhance your career with year-round educational programs. There's an online resource for you. Membership has its value. It's very critical, and it's very important that you keep learning. And I don't care if you're an electrical engineer, mechanical engineer, you're an HVAC technician, you are you have a technical degree, you're a labor. I don't care if you're union, you're non-union, electrician, you own your own contracting firm. This is an organization where everybody joins under one envelope, one roof. We all work together, and we focus on safety. That's what the IAEI is all about. So I just wanted to at least close this session. After talking, hopefully you got something out of series ratings. Remember that a series rated solution is, 100% rated solutions. You're going to take that route when you want to try to save some money on conductor. But don't forget, the equipment is going to be different. The panel board, the structure, the circuit breaker. Now, if you're in medium voltage equipment, don't worry about it. Big assemblies, low voltage assemblies, you're already 100% rated. But the bulk of what we do is in molded key circuit breakers, fusible switches, things of that nature. All of that stuff is not 100% rated. 80% rated is what it is. You're using a little bit larger of a conductor for the current, the load that you're serving. It's a continuous load. That larger conductor helps reduce the heat and get the heat out of that enclosure, and we test that way. Unless it's 100% rated, which means the breaker, the fusible switch, the enclosure size, the bus structure that's inside that enclosure, all of that makes a difference. So hopefully you learned a little bit more about that topic. And if you have questions about it, please send us an email. We'll look forward to hearing your questions, or leave a comment to this video. I look at the comments. If I see questions in there, I will try to answer those, either one-on-one, or we'll do another program on just Q&A. All right. Thank you for joining, and hopefully you had a great Labor Day weekend. I hope you had a safe Labor Day weekend. And I hope your whole week is safe and healthy. Alrighty, everybody, I want you to take care, stay safe and healthy, and please come back next week. We will see you next Tuesday, right here, same channel, same time, 12 o'clock Eastern. Thomas Dimitrovich saying goodbye until next week. Thanks.